You. Yes, you. Did you do your daily LeetCodes? Did you do your daily LeetCode today? Yes, you. Who am I asking? You, the viewer. Did you complete your daily LeetCode? I certainly did not. Usually we do it at early in the morning, and I didn't do it, so I failed. I failed the squad. But at least we're getting to it now. It is quite late in the day. Running on E, minimal brain juice remains. It'll be a miracle if we are able to solve even one problem. So that would be pretty epic. That being said, we have a lot of comments to get through, and it's particularly late in the day. Also, development on a project continues, and I actually don't think I switched projects. I know we probably shouldn't keep switching projects, or otherwise you end up with unfinished project syndrome, and I have many projects in the graveyard, so I don't want to do that. But this project, I think, is definitely simpler, shorter, and a little bit larger in scope, slightly. I mean, if we could rate a power level for this, it was about a 33, and the next one is about a 34.5. But I think it's more closely aligned with just some things I want to try and do, and the next project will actually be usable. So it'll be pretty cool. We shall see. Maybe I'll make a documentary, not a documentary, but like a documentary style video where I talk through how I made it and what stuff I did and stuff like that. There's a couple different people who make videos like that. Would be cool to see. That besides the case though, it is day 113, and that is pretty dope. Mostly because it's day 113, and we have quite a few comments. We have Clappy, which I'm guessing I'm guessing they do a lot of C. So that would be pretty epic. Really putting in that pain. True. But please train me in the way of C, Sensei. Respect. Respect. Front end for T. Actually, front end is pretty dope. So I feel like there should be like a LeetCode for front end. So if no one makes that, that's what we're gonna make next, or next. But there should really be a LeetCode for front end, and there isn't, which I don't really understand why. And this person said, "Who knew Too Mad could code?" This is actually funny because I remember watching or seeing a thumbnail one time, and I was like, "Wait, this dude kind of looks like me." So yeah, that's pretty funny actually. Boteo with the laughing emoji. Thanks for the channel. Do you put in a minimum number of hours every day on LeetCode? And this is a question by Shantanu Shakar's June RFT. I'm sure I butchered that, so thank you for the patience. But do we put in a minimum hours of LeetCode, minimum number of hours of LeetCode? The minimum number of time I try to do is like 15 minutes. So I started with 15 minutes. I did like 74 days of that, and it slowly rose to about 30 minutes. No, yeah, I think it was actually 15 to 20 minutes. And then after that, on day 75 of me doing it in real life is actually day 1 on the channel. So the minimum number is 15. That was just to build a habit. And the other thing was just to commit to the most you would do on your absolute worst day. So imagine the worst thing possible happening to you. You just got laid off, or you ordered a coffee and they put one too many sugars in it, and then you get laid off at work, and then you come home, you're about to go into your door, you're about to go into your house, except you drop the keys. And that's like the worst possible day. So you drop the keys right before you put them into the door lock. That's how much. Ask yourself, as you're putting the key into the door after you've picked it up, actually as the key has fallen, ask yourself, how many minutes of LeetCode do I want to do right now? And that was 15 minutes. So we did 15 minutes for a while. But yeah, that would be 50. It would be 15 minutes. But nowadays it's mostly an hour. So the 15 minutes really helped to build discipline. So now definitely have an ability to go for longer now. So yeah, I've still got a long ways to go though. So we're averaging about an hour a day. And even before that, if you scroll back on the channel, but there are some videos that are like 1.5 hours or 2 hours, but try to aim for 1 hour a day, which I think is sustainable. There's 24 hours in a day. You need 8 hours to sleep, 8 hours to work, leaves you 8 hours left. And on the worst case, hopefully one can get to an hour, but it definitely took me a long time to get there. There was someone else who was able to do much longer. I think it was Niall or another person, but there's few people have been able to do far more than that, and that is incredible. Like, so if you can do more, always do more. But I try to commit to, yes, 15 minutes on the worst day, but I always do more if I can. And yeah, so yeah, that's what I would say that would be the minimum. And I think that should be all these equipments. But yeah, what was I gonna mention? I would say, yeah, that's about it. Another thing I was thinking about, it just seems strange. I was sitting on my couch last night and I was thinking, I forgot to make a video, and then I checked YouTube Studio and I was like, oh, I did make a video. So I think there's something just strange about routines where, you know, you ever like driving and then you end up somewhere and you're like, how did I get here? It feels like that, and maybe that's the point of routines. You know, you try to make something a routine, and then time just goes on like fast forward. So I remember in college, time would go so slow, and then as soon as I started working, it feels like I'm on like 4x speed, which is very strange. And I guess, you know, there's quite a few different thoughts on this. Some people theorize it's because as you're getting old, as when you're younger, there are more novel experiences, so everything seems new. Since everything seems new, when something new happens, it's like a core memory, like stains your brain or stains your mental memory bank with this event. And so when you think, oh, what did I do this week, you can probably pick out like 30 things because there's so many new things that happened. And I guess as we get older, there's just less novelty. So maybe that's why things speed up. But it's very interesting. I remember reading the book. I should talk slower. I remember reading the book Moonwalking with Einstein, which is a pretty cool book about memory palaces and the tools our ancestors used to use to pretty much pass down databases, you know, pass down that Postgres database from one generation to the next. And they're using memory palaces. But there was a person in the book, the guy basically tells a story of him becoming an apprentice to like a legendary memory palace person, and then eventually at the end of the book he wins the memory palace championship. So he gets really good at remembering stuff. Throughout this journey, he meets a young man who theorizes that life goes by so fast because we cannot remember any of the novel events. So using these memory palace techniques, he plans to slow down time, or at least his perception of it, by encoding all of these novel experiences in a memory palace. And it definitely seems possible, since the memory palace people have memorized entire books, entire dictionaries, multiple books, just entire books. Someone mentioned in the book that someone mentioned in the Moonwalking with Einstein book that they had memorized a couple of books, and that he said one should have enough information in their memory palace to provide them with a day's worth of entertainment. So you could just read a book in your head. So it definitely seems possible in terms of the bandwidth required, and how much compression is required. Definitely seems possible that one could memorize everything that happens every day to slow down their perception of time. And yeah, I think it definitely would be pretty cool. So maybe this is probably a pretty fringe and meta idea. Maybe one could deal with impatience by modulating these characteristics. For example, high school seemed like an eternity. So what if, maybe because there's a lot of novelty happening, even though we might not say it, but there is, right? And then after you get from high school to college, there's more novelty, but not as much. It goes a little faster. But when you start working, there's just a lot less novelty. So I'm wondering if one could modulate impatience with these, one could modulate time because of impatience using these techniques. So it's definitely interesting. So I used to think, oh man, it's going to take me forever to do all these LeetCode problems. But now, since I kind of have this routine, the days kind of blend together. So 10 days, 30 days, or I wouldn't say 30 days yet, but 10 or 15 days kind of feels like 2 days now, which is really strange. And I think it's because of the LeetCode in the morning. It's just very, very interesting. So maybe routines are unbalanced. Maybe that's a new cheat code, and maybe there's going to be a balance patch from the heavens, and you won't be able to abuse this anymore. So you're going to want to abuse this cheat code, and the cheat code you need to use this is going to be in the hyperbolic coding chamber, the Discord linked in the description below, which you're going to want to join for tons of tips and tricks, as well as a cheat code to put into any terminal, which is going to allow you to spawn a instance of GPT-4, not 3. We just got a secret update from OpenAI, so we just embedded this application in all running applications today. It's part of the NPM package, so you're going to want to be able to know how to invoke this from NPM, okay? And it's just NPM space GPT-4 space the secret code. The code lives in the Discord, so you're going to want to join the Discord for that. And this is actually true, and it works. So you're definitely going to want to join Discord for that. And yeah, we're just going to jump into it today. We have an hour to be done, an hour of misery. I'm relatively certain I have pink eye. So yeah, we're trading once again LeetCode. Once again, we're trading our health for LeetCode. Also, we're doing LeetCode, but make sure to go ahead and focus on heart health as well. So hopefully I can do that as well. Haven't really found a method to make cardio work yet, but figuring out how to solve that puzzle. And yeah, we're just gonna jump into today's LeetCode grind. Also, this next frame is for the thumbnail. Okay. So, yeah, we have, I guess, yeah, we're working on guess number. Oh, no, I think we went in reverse. I didn't really feel like doing guess higher or lower. Also not a big fan of the new LeetCode UI, but we shall get into it anyway. So we are playing the guess game. The game is as follows. I pick a number from 1 to n. I pick a number from 1 to n. You have to guess which number I picked. Every time you guess wrong, I will tell you whether the number I picked is higher, or every time you guess wrong, I will tell you that whether the number I picked is higher or lower than your guess. You call a predefined API int guess int num, which returns 3 possible results. -1, your guess is higher than the number I picked. Num is greater than pick. -1 means my guess is higher. 1 means your guess is lower than the number I picked. 0, your guess is equal to the number I picked. Return the number that I picked. So if n equals 10, pick 6, output is 6. Right, and I guess what they're saying is n is less than or equal to 2 to 31 minus 1. And I'm guessing we can call guess as many times as we want. I think that might be how this one works. So if that is the case, I think this is just code for binary search, because these ideas would map pretty closely. Right, we have a range, right, from 1 to n. Then we have to guess a number the person picked. We can guess any number, and our number that we guess could just be the pivot. Wait. Oh, and guess is defined, which is a function. It's just not passed in here, I guess, which makes sense. And let's just return guess. It's not defined here. But it should still run. I wonder if it'll give me a TS error. Right, so this does work. Okay, so guess is defined, it seems. It's just we don't actually get any type information for it, so we'll just define a type later. But The range is from 1 to n, and we can guess, using this guess API, we can input a number and enter whether or not, and it'll return whether or not our guess is higher, lower, or equal to the number. And then at the end, we have to return the number that they picked. And the n passed in here must be the top range. So I'm thinking the approach we could use is a binary search based approach. And we need, I'm guessing our runtime would be log n. And it seems very possible that this would work. We also don't have any type information for guess, so we could just say type guess. We just call it guess func. Actually, we'll just call it guess API. And we'll return 1 to start. And then I forgot how you declare a type in TypeScript, but I think you can just say it's going to be a function which takes a number and returns a number. This is cannot find name guess, which is okay. Oh, and oops, I did this as a parameter. It has to be a return. So I think we should be good. If we do guess API, it should return a number. So we use a binary search based approach where left, right? Our left hand side of our boundary is going to start at 1 because they mentioned that they pick a number from 1 to n. Start at 1, and we'll say let right equal to n. We'll say while left is less than or equal to right. Is a number that they picked always in the range? And it looks like pick is always in there. So we don't have to worry about returning here since it looks like we're always going to exit up here. But we need to calculate a pivot. This pivot is going to be equal to left, right, plus the math.floor of right minus left over 2. It's going to give us our pivot. And then our pivot is what we're actually going to use as our guess. So we're going to say output is going to be equal to guess API, right, pivot, right? And if output equals 0, right, then we want to return pivot because it means we found the number. But I think, right, if output is equals -1, then what did they say? If our output is -1, our guess is higher than the number I picked. If our guess is higher, then that means every number past our current pivot is also higher. So we'd like to set right equal to pivot -1. Else if output equals 1, our guess is lower than the number. So if our guess is lower than the number, it means every element less than pivot is also too small. So we'd like to move left up to where the pivot is, +1. We're adding 1 because we already processed the pivot. We don't want to include it. And I think this should work. Example, if n is equal to 10, we're going to calculate our midsection, right? We're going to go from left is equal to 1 up to right, which is equal to 10. We're going to do 10 minus 1 gives us 9 over 2 is 4.5. Floor is 4 plus left, which is 1, is 5, right? We're going to guess, right? 5 is lower than 6, right? If it's lower than the number they picked, then we get 1. So we get 1 here, we'd say left equals pivot plus 1. Left is now going to be equal to 6. And then that does make sense. It looks like the regular binary search mechanism would work. I see. So this does look like binary search, but with extra steps. So I wonder how they solved it. So we can take a look at that. We check every number from 1 to n-1, pass it to the guess function. The number for which a 0 is returned is the required answer. So that would be linear time. True. Linear space. Binary search is what we did. Ternary search gives you log base 3 of n. Binary search, we choose the middle element as the pivot in splitting. In ternary search, we choose 2 pivots, say m1 and m2, such that the given range is divided into 3 equal parts. If the required number is less than m1, then we apply ternary search on the left segment of m1. And if num lies between m1 and m2, we apply ternary search between m. Otherwise, we will search in the segment right. This is crazy. It seems that ternary search is able to terminate earlier compared to binary search. But why is binary search more widely used? Ternary search is worse than binary search. Following outlines the recursive formula to count comparisons of binary search in the worst case. Following outlines the recursive formula to count comparisons of ternary search in the worst case. So it does look a little worse. But this one's log base 2 and this one is log base 3. 1 plus 4 log base 3 of n and 1 plus 2 log base 2 of n. Determine which is larger, we can just look at the expression 2 log base 3 of n. Interesting. I didn't know ternary search was a thing, so we learned a new thing there. I wonder if it'll be useful later on. So we have find the difference. Here you're given 2 strings s and t. String t, you're given 2 strings s and t. You're given 2 strings. You are given 2 strings s and t. Okay? String t is generated by random shuffling. String t is generated by random shuffling string s. String t is generated by random shuffling string s. Okay, and then add one more letter at a random position. Return the letter that was added to t. So you have A, B, C, D, and t was generated by shuffling s and adding one letter. E is the letter that was added. So s is equal to this, t is equal to one letter that was added was y. S and t consist of lowercase English letters. It seems like maybe a potential solution could be 2 maps, and we'll do this one in Ruby. Potential solution could be 2 maps in the sense that we'd have one map which is going to map a key, which is a letter, to an occurrence. So A to 1, B to 1, C to 1, D to 1, and then we could iterate through T as well and create the map. And what we'll do is then we can just iterate through both maps. Well, we can iterate through T as a map, And we'll just say, okay, does A exist in S? Yes. Okay, do the occurrences match? Okay. And then we'll keep going through, and in both cases, we have two cases, right? If key not in S or occurrences don't match, that's the letter. That letter was added. So I think that could work. Let me see if we can generate something that doesn't make sense. S is always t.length plus 1. Or t.length is equal to, that's just strange. T.length is equal to s.length plus 1 is a strange constraint. I think what they mean is s.length is equal to t.length plus 1. Otherwise, this is not equivalent, right? S and T consist only of lowercase English letters. So we could do it in linear time constant space, since all the values in the map would be bounded by the subset of all lowercase English letters, which would be 26 indices. If that's the case, we could try it. We could call it smap is equal to hash.new, and the default value will just be 0. Actually, we'll do no default value. Actually, let's do a default value. No default value, because we don't know when the... Actually, yeah. Sorry. We can do a default value. We'll use key to tell if a key exists. And what we'll do... looks like our environment just got messed up. We'll create a function called create hash, which will take a string. And we're going to have hash, which is equal to hash.new. The default value will be 0. We'll say string.each do letter, and we'll say if, actually we can just do value equals if hash dot has the key for letter, right? Then we just want to get the occurrences for that letter. Otherwise, we want to get 0 because it doesn't exist. I'm realizing since we have default values in Ruby, we actually don't have to do this, so we can just say if hash dot, if we have the key for the letter, then we'll just say hash sub letter plus equal 1. And then we can just do hash. So if we do s hash equals create hash s, and then we can duplicate this. We puts t hash, and then we'll just return character A to start. So you can't do each for string. So we'll do split. Both of our hashes are empty. Oh, right, and our, oh man, our else case has to be hash sub letter equals 1. Right, so we could do what we did earlier. Yeah, we fumbled that one bad. We'll say value equal if hash, if we have the key for this letter, right, then we just want to get hash sub letter. Otherwise, we want to get the value of 1, and we'll just say hash sub letter equals value plus 1, and we'll change this to 0. So if the key doesn't exist in the hash, we'll set it to 1. Otherwise, we'll set it to the value and add 1 to it. Okay, now our values do exist. So now you can see that the difference is here. And presumably, since t is the larger hash, we'll just do t.each do letter and occurrences. We'll say if s sub hash, right? Like we said, we have two cases. If the key is on s or occurrences don't match, that letter was added. So we'll check the two cases. If s sub hash dot doesn't have the key for a letter, or if s sub hash sub letter is not equal to t sub hash sub letter, we want to return letter. I think this should work. So we're iterating over letters and occurrences. If s hash doesn't have a key for the letter, it means it was added. Or if s hash is occurrences, which we don't actually have to do t sub hash, so we can just do sub occurrence. We just do occurrence like this. Then we'd like to return the letter. It looks like a letter is always added. I said linear time, but I think it would be s plus t time, which I guess technically would be linear time. Is there a faster way to do it? I don't think so, because you need the hash, so you have to visit the whole thing at least once to know if the... You could also do this with, instead of a hash, you could do it with a character array as well. S plus... Oh, sorting would be clever. That's true. Sorting would be clever. But that space would not be Gould. If we use the hash map, you get linear time with constant space, and there's a bit manipulation solution, which is still linear time, so it doesn't seem worth it. So we have another string problem. Given two strings, s and t, given two strings, s and t, return true if s is a subsequence of t. So I guess if we have a string like cat, dog for t, we want to return true if s is a subsequence of t, which would mean that they don't have to be contiguous. A subsequence false otherwise. Subsequence of a string is a new string that is formed from the original string by deleting some, can be none, of the characters without disturbing the relative positions of the remaining characters. Ace is a subsequence of A, B, C, D, while AEC is not. Definitely don't want to use a map here. We probably want something sequential. And I think subsequence is just a subset of sliding window, except you wouldn't... ABC, iterating through, we'd have A, have one character that we want. H isn't the character. B, C. I think there's a way to do this with a map. T consists only of lowercase English letters, so we can do it in constant space. Suppose there are lots of incoming S. Say S1, S2, SK, where K is greater than or equal to 10 to the 9. You want to check one by one to see if T has its subsequence. In this scenario, how would you change your code? Yeah, so I'm definitely thinking map, because now we can pre-compute our answer. So I think the goal time complexity would be like the last problem. Last one we did in Ruby, with this one in TypeScript, it would be O of S plus T with O of 1 space. Since S and T consist only of lowercase English letters, you can use linear. You can use 26 indices in the map, which would be constant. Would be constant space, since would be our map keys would be bounded by the subset of lowercase English letters. I think the intuition would be to iterate through both strings and create a map of letter to occurrence, and then for a letter to occurrence of T, right? And then for every character in S, what we could do actually, this algorithm would be n squared. Actually, no, it would be far worse than that. What I was thinking was we could create a map of all the characters in T and their indices. For example, A would map to index 0, H to index 1, B to index 2, and then we could just iterate through S and just make sure that A's index is less than B's index, which is less than C's index. ABC T equals AH BGDC. ABC T equals H BGDC. S equals ABC T equals H BGDC. So lots of incoming S, say S1, S2. Wait a second. S equals ABC, AH, BG, DC, AXC. There's a version of this with sliding window pattern, I'm pretty sure. Except maybe you would just never reset the window. Yeah, what if we just never reset the window? So we'd have a window, let's say, of 3 characters. We'd say cars left, or we say cars needed, right? We could start at 0 and work up to s.length. And we'd say, okay, have we found a character with length A? We have. Have we found one with character equal to B? Yes. Found a character equal to C? Yes. And the characters needed would equal s.length, so we'd return true. Now, if we make it to the end of T, right, and we still have characters needed, then we return false. I feel like this makes sense. In that case, the time complexity would only just be T. Is there a version of that that doesn't work? If we have a subsequence like ACE, can we duplicate the letters such that ACE is not available? Right, because we have to find A first. Once we find A, it doesn't really matter when we find the next A, we're just looking for C. Find C, then we move on to E, and we find E right after. I think this could work. The time complexity would be O of T. So we'd say, like we said earlier, cars needed, it's gonna found of equals 0. And we want cars found to equal S. And once it does, we'll return true. So at the end we can return cars found equals s.length. And what we'll do is just do car of T I think we could just say if T sub cars found equals S sub cars found. No. If car, right, so if the current character that we're at in T equals S sub cars found, should be A, right? Then we want to say cars found plus equal 1. Then we could early exit as well. We'll say if cars found equal S dot length, return true. So let's try this. Cons car T would be at A, right? We'd say, okay, does A equal S sub cars found, which is 0? It does. So we'd say, okay, cars found plus 1, which is not 1. So now it's B. Okay, and now we're at H. Does H equal B? No. Does B, which is car, equal S sub cars found, which is B? Yes. Cars found plus 1, we get C. We keep going until we find C. And I think this version should force that each index, for each index in S, where each index is defined as S sub I dot going to S sub n should be less than or equal to S sub I plus 1. Maybe. I think this should work. The test cases at least. Interesting. So it does seem to work. Interesting. So I would say this is O of T. Since S is going to be a substring of T, it means that T is the worst case of O of T with O of N. It's O of, oh, no, actually, yeah, O of 1 space. Oh, there's a divide and conquer. Seems like it's still O of T. And the space is still. Designate 2 pointers for iteration, with the left pointer referring to the source and the right pointer. It's kind of what we're doing, left and right pointer, which is 2 pointers. Interesting. Wait, we did it, but it says... Oh, okay, well, it says we did it, so that's fine. Now we'll try... a binary... A binary watch has 4 LEDs. Binary watch has 4 LEDs on the top to represent the 4 hours. Binary watch has 4 LEDs. Binary watch has 4. I wonder if the text isn't too big. Okay. Binary watch has 4 LEDs on the top to represent hours 0 to 11. And 6 LEDs on the bottom and 6 LEDs on the bottom to represent the minutes. Oh, I see. Because you can just turn them on at specific times. Each LED represents a 0 or 1 with the least significant bit on the right. For example, the below binary watch reads 4:51. Right. Looks like base 2. Given an integer turned on, which represents the number of LEDs that are currently on, ignoring PM, return all possible times the watch could represent. May return the answer. Ooh, that's actually kind of hard. All possible times the watch could represent. You may return the answer in any order. The hour must not contain a leading 0. For example, 01 is not valid. It should be 1. The minute must be consisting of 2 digits and may contain a leading 0. For example, 10:2 is not valid. It should be 10:02. Turned on equals 1. These are all possible values. Turned on could be 1. Turned on is capped at 10. I think that is pretty crazy. Maximum number of LEDs that can be turned on is 4, right, plus 6, just 10 LEDs. I was thinking we could make this a graph problem. Then I think we'd have 10 factorial numbers, which is crazy. And I'm pretty sure 10 factorial is ridiculous. Oh, it's actually not the worst, but it would be really slow. Could you do it when you have two? When you have see, you can usually brute force something with two for loops. You get n squared. Could I do that here? Except would the number of for loops correspond or correlate directly to the number of LEDs turned on? Is the question. That is indeed the question. That is indeed the question. Turned on is equal to 9. A binary watch has 4 LEDs on the top to represent the hours 0 to 11 and 6 LEDs on the bottom to represent the minutes 0 through 59. Binary watch has 4 LEDs on the top to represent the hours 0 through 11 and 6 LEDs on the bottom to represent the minutes. Maybe another question that could be asked. This says 4, not 5. If 9 are turned on. 9 are turned on. Ignoring the PM, okay. Return all possible times the watch could represent. You return the answer in any order. How is it if there's 9 LEDs on? There's 9 LEDs on. If there's 9 LEDs on, how is it possible? If there's 9 LEDs on, why is it the output is empty? There are 9 LEDs on, the output is empty. It would be, these 4 would be on. 4, 5, 6, 7, 8, 9. 13. Oh, you have 32. 16 is 48. 48 plus 8 is 56. Oh, 56. Ah, if the sum is greater. If the sum is I see. That's a good point. If min sum greater than. If it's greater than 60, then it's not a valid time. That is interesting. How can we generate all of the available times? How could you generate all available time? If they were all the same, I could see it. Maybe if you parallelize the all right, maybe if you parallelize the generation of all the values, right? So if we generate all the possible versions, because we have to assume that if they say 9 are turned on, then the first 4 LEDs would go to the hour slot. Or maybe they wouldn't. Well, let's see. What if we try a different case like 2? Even 2 should give us a lot of numbers. So you have 3, 5, 9, 10, 12. Basically, okay, so the version I was thinking of doing based on the answers, I was going to generate all possible versions with 2 LEDs for the hour hands and the same for the minute hands, and then just what we call do set multiplication on it, but it doesn't seem like that makes sense. Of the ones generated, we have 101, 102, 104, 108, 116. I wish they showed us how fast their version was. Generating all possible values of something. Maybe the best version of this problem is a graph version. That's the best way I know how to generate all possible versions of something, is with a graph. What if we start at 0 and we'll just try turning on all the bits? So if we figure as if we frame as graph where root equals 0 bits turned on, we could frame it as a graph problem where we visit all versions of the bits, where the string is represented as something like this, where the 4 zeros represent the 4-hour bits and the 6 zeros here would represent the minutes. And here we just have to visit all versions of this graph. And so how we would do that is we would start with 1-bit 0 set. If we start with 1-bit 0 set, then what we can do is run a for loop where we now, actually no, what we would do is just visit all versions. So we just would call two calls of next bit, right, which would branch the graph into, or I guess we do 2 calls of it, one that starts at 0 and it starts at 1, but this graph would branch into something like this and something like this. And the next bit, right, would be 1, so on, but this seems like it would take forever. Maybe you can do the same thing with the for loop. It seems like, actually now that I'm thinking about it, we just have a string with 4 zeros that we want to generate all possible versions of. So what if you start at 0? Start at 0, then we go to the next indice. That would be, we need at minimum X amount of bits set though. Yeah, that has always been an issue. I don't know how to generate all possible permutations of something. Yeah, I think you could even rephrase this problem as, it's just if we had the string 1, 2, 3, 4, 5, 6, 7, 8, 9, how many different ways can you arrange it? Is what we could phrase this problem as. And then you just have to generate all the times based on the remaining on the strings generated. So maybe before tomorrow I'll read a little bit on the ADM. But we still have 3 minutes, so maybe we can think of something. Hmm. 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 How to generate all different versions. Move. Yeah, I'm gonna have to think about this one. How to generate all. The problem boils down to just generating all value versions of it. So we'll have to figure that out, but we'll stop there.